Hi, in this tutorial I'm going to show you how to work with the different graphical outputs generated by fruits. And to illustrate this, I took a random example, which is this model that you can see here. Now, this is a diet reconstruction example, but everything that I'm going to say next is of course valid if this was a generic model of any other type. The only real difference is of course the labeling. Here I'm going to refer to consumers and food groups, whereas in a generic model I would be talking about targets and sources. Okay, now this is a model with two consumers and two food groups. So we have our consumer 1 and consumer 2, and we have in terms of food groups, marine food group and terrestrial food group. Now, when you have more than one consumer or more than one target, as an output, this graph will be generated. So group box plots. This, of course, will not be generated if estimates are being generated just for one consumer or just for one target. So what can we see here? Well, here we have our two consumers, 1 and 2, so identified by the same IDs. And we have here our two food groups, marine and terrestrial. And what you are seeing here, because marine is selected, and you can also see it here in this header, are the estimates on the contribution from marine foods towards consumer 1 and consumer 2. So what do the box plots mean? Well, the whiskers, so from here to here, they represent a 95% confidence interval, whereas the boxes from here to here, they represent a 68% confidence interval. The continuous line represents the estimated average, and the discontinuous line represents the estimated median. Okay, now if you want to see the estimates for the terrestrial food group for these same consumers, what we do is select terrestrial and then double click on the left button of the mouse. So let's do that. And now you have for consumer 1 and 2 the estimates for the terrestrial food group. Notice also that the label, that the heading has changed. You can choose to have this heading either visible or not. So how can we export this image? Well, you can do this in two ways. You can right click anywhere over the graph, and if you want to copy it, you can select this option here, copy, and then you double click on the left button of the mouse. And then we can paste. You could also, for example, let me delete this previous one, paste it into a Word document or other types of files. So I'm doing Control V, and here it is. Okay, let's do it again. Deleting, Control V. Okay. You can save, instead of copy pasting, you can save this image, and for that you right click over the graph and you select Save As, and then as the same as before, you double click on the left button of the mouse. And it gives you different options on how to save this image. The two first ones are vectorial formats, and these are raster formats. These are vectorial formats which are native to Windows. So let's save it as vectorial format. Let's give it a image, and let's choose, for example, EMF, and let's save it in a desktop. Okay. Now, if you save it as a vectorial format, this means that you can use a vectorial software to edit these images. And there's a pretty good vectorial software available for free out there. It's in Inkscape, and I'm going to use Inkscape to illustrate what you can do with this image. So I'm going to open it. Here it is, opened. Okay, and here you have it, and you can edit any of these elements. Since now this is a vectorial image, so I could just delete this, or I could change here the font size. I'm going to do this. Okay, wait a minute. Not really. Text and font. Yeah. Okay. Let's change. Apply. Okay. So you can do a lot of things using software similar to Inkscape. If you are using Inkscape on Mac or on Linux, you might have to add a plugin to be able to work with these vectorial formats. Okay, let me close this. Close without saving. Now, another output that you have, and that you will also have in case you only have one consumer, it's this one, the box plots of results. And what it gives you is for one specific consumer, in this case consumer 1, that's the one which is selected, what are the estimated contributions from the two food groups, in this case marine and terrestrial. And the interpretation of the box plots is the same as before. Again, you can copy or save as, and you have the same available options as before. You also have a header, but now what's being shown in this header is different. So what you have first is the identification of your target or consumer. So this is consumer 1. Okay, 1. But you can show the estimates for consumer 2, and you select consumer 2, and then you double click on the left button of the mouse, and now you have the estimates for consumer 2. It also shows you what were the input values. These input values here are the same as those here for each consumer. It shows the so minus 15 here, minus 15, and then the uncertainty between brackets. Okay, and then the 15n, that's 12, that's 12, and then the uncertainty. And this can be very useful in case you have multiple of these outputs and you want to be able to assign it to a specific consumer. Okay, again, you may opt to have the header visible or not. Okay, so let's, for instance, copy this, and then I'm going to paste it here without the header. Okay, and finally you have the graphical output for the probability distributions. Okay, as before, you can select the results to show the results for a specific consumer. In this case, it's consumer 1. I can select for consumer 2, or going back to consumer 1. The header is the same as before. And these probability distributions are color-coded according to food groups. So the red here is the marine food group, and the green one is the terrestrial food group. You have two types of graphs. You can, for the probability distributions, you can plot these probability distributions as a graph type consisting of columns, or you may opt for smooth area. You select these by double-clicking. Okay. If you are not happy with this graphical representation, you can choose to represent these graphs using other softwares, and you can do this by exporting these data points. So you just click to export data point, and this will be for consumer 1 because that's the one that is currently selected. So let's call this consumer 1 probability distribution. Okay. Save, and here it is. And then you can use whatever software to create your graphs for probability distributions. Let me show you how you can do this, for example, using Excel. So you have here your your data. So this goes from 1 to 100%, and you have your probability densities for the marine and for the terrestrial food group. So I'm going to do a Control A to select all the data, and then Control C to copy it, and I'm going to paste it here. So I'm going to show you how you can do this, for example, using Excel. You could use other softwares. Okay, so let's say you want to plot the probability distribution for the marine food group. You can select all this, and then you can do it insert, scatter, and here you have it. And so this blue series, that would be your marine food group, and now we want to have also for the terrestrial, add let's call it terrestrial, and then we have to select the same X values. Those are the percentages, and then we have to select the density distribution for terrestrial. Okay, let me change this to marine. Okay, and here it is. Now Excel is not the best software to do this, of course. There are many better options out there, but I just wanted to illustrate how can you use these data points to create your own graphs. And that's it.